Today we're going to start off by talking about Unit 3, Notes 1. So we're going to start, this is our very first notes video of Unit 3. So talking about Notes 1, we're just going to go over some definitions, some stuff you need to know for this unit. So today's going to be a lot of vocabulary, and these are good words to be using when you're filling out those CFAs in the future. So let's go ahead and let's start by taking a look at what a term is. So I'm going to go ahead and pull this over. So a term is a number variable or the product of a number and or variables. So remember, I'm able to talk a lot faster than you're able to write. So what you might want to do is pause the video so you can get this written down because you will need to know this vocabulary. So a term could just be a number. So it could just be something like 4. A term could also be a number or just a variable. So it could be x, or it could even be x squared. Or it could be the product of the two, so it could be something like 4x squared. And it could be both. Okay, so that's what a term is. Next, let's go ahead and take a look first and foremost at a coefficient. So a coefficient is the number factor of a term that has a variable. Now that's actually a lot more confusing than it sounds a lot more confusing than it actually is. So we've dealt with coefficients before. You've heard that term hopefully before. So let's take a look at what a coefficient is. So let's say I have something and it's 3x. All that's saying by the number factor is that this 3 right here is the coefficient of the term 3x. So if you have something that says 6x, your coefficient would be 6. It's that number that's being multiplied by your variable. Next, let's take a look at the degree of the term. So the degree of a term is the exponent on the variable of the term. So what's an exponent? Well, that exponent is that little number that it's raised to. So let's say we have something like 4x squared. Okay, so if we have something like 4x squared, the degree on the term would be this guy right here, that exponent. So if it's a 2, then we would say that this term right here, because of that, we would say that this is a second degree for the term. Now, as I'm going through these, I want you guys to write your own example. Okay, so I want you guys to write your own example about what this is going to look like. So write your own term, then tell me what the degree is going to be. Next, let's take a look at the constant. So the constant is usually for students the easiest to remember. So a constant is a term that only contains a number. So if we have a bunch of terms being added together, a constant is the thing that's just a number. So a constant, it could be 6. It could be 7. And it looks like I skipped down a little on your note sheet, so it kind of flip-flopped. So hopefully you're not writing it where it says constant. Okay, so let's go back and let's take a look at like terms. So like terms, okay, so again, you know, this is a lot to write down. It may not fit in the box, so write down what you need to remember what a like term is. So a like term had the exact number of same variables raised to the exact same exponents. So likewise, all constants are like terms. Well, that's a lot of mumbo jumbo. So let's put an example so that makes more sense to us. So for example, all same variables raised to the same exponents. We could have 4x squared and 3x squared. Those two would be considered like terms because they both have an exponent of 2. So that makes them like terms. Okay, likewise, we could do ones that are just numbers. So for example, like we did up top, 6 and 7. Those constants are also like terms. Okay? Next, let's take a look at the definition of a polynomial. So the first thing you need to be thinking about is the fact that poly means many. Poly means many, so we're going to have many terms. So all a polynomial is it's a set of terms being separated by a bunch of pluses and minuses. So let's take a look. Let's write our very own polynomial. So I'm going to just write it out. So I'm going to start with x cubed. So I'm going to have 4x cubed minus 3x squared plus 6x minus 2. So all of those things are terms, and because they're being separated by pluses and minuses, we have a polynomial because there's many. Poly means many. There's many terms that are being added together. So next, let's take a look at the degree of a polynomial. Let's pull that on over. So the degree is the largest exponent of all the terms in the polynomial. So the largest exponent of all the terms. So let's go ahead and let's write out a polynomial to start off with. So we have for a polynomial 4x squared minus 3x plus 2. So now we talked about how the degree of the term is the exponent of the term. So to find the degree of the polynomial, we want to find the highest exponent, the largest exponent. So the largest exponent in my polynomial is 2. So that makes this a second degree polynomial because our highest exponent is 2. So that's a second degree polynomial. Next, let's go ahead and drag this guy over. So this is a lot of information. So again, just write down what you need to know to remember, okay? So a polynomial is in simplest form. Okay, so big thing to point out there is that all like terms are combined. Okay, so we don't want to have x squared and then later down minus 3x squared. We want to combine those like terms, so we can take x squared minus 3x squared and combine those like terms. And also another really important thing is that all of our terms are written in descending order of the exponent. So our largest exponent is at the top and then our next exponent. So if we look up, let's write a polynomial. I'm just going to write a bunch of polynomials. 3 minus 4x to the 4th plus 2x squared minus 3x cubed. So I just wrote out a polynomial. I just made that one up off the top of my head. Now I want it to be in standard form. Okay, so for it to be in standard form, I need to combine like terms. So I notice that I have a 3x cubed and a negative 3x cubed. Well, when I combine those like terms, those guys are going to cancel out completely. So all I'm left with really are these 4x to the 4th and this 2x. So I just want to make sure that I write them in descending order. So I have negative 4x to the 4th plus 2x squared. And that is going to give me my standard form of the polynomial. Okay, let's take a look at some more vocabulary. So let's take a look at the leading coefficient. So remember we talked about the coefficient being the number factor. So we've already talked about it being the number factor. Now we want to talk about it in terms of the entire polynomial. So it says that the leading coefficient is the coefficient of the first term, but that's also assuming that the polynomial is in standard form. So let's write a polynomial that's in standard form. So we have 4x squared minus 3x plus 1. That's a polynomial that I just made up. Again, be writing your own example. See if you can take that vocabulary and show me what it looks like. All right, so the leading coefficient, first thing I want to find is the largest exponent. The exponent is the little number. The largest exponent is 2. The leading coefficient is the coefficient with the term with the largest exponent. So for this one, my leading coefficient is 4. Okay, now let's put this vocabulary into practice a little bit. So let's go ahead and I just want to take a look and I just want to show you something about like terms. So let's let x represent a line. Let's let x squared represent a square and x cubed represent a cube. So I just want to kind of take a look at this. You guys don't have to write anything down. I just kind of want you following along for your own benefit. Okay, so I'm going to put up here and I'm going to have 5 cubes up here. So blue is going to be my positive amount of cubes. Well, then I have a negative 2x squared, so I'm going to go ahead and I'm going to put the 2 negative squares. Then I have a positive line, oops, if I can get it, positive line. Okay, and so what I'm trying to show you guys here is that cubes can only be added with cubes. So let's just take a look. So we have a negative 2x cubed. So these positive cubes can only be canceled out by negative cubes. They can't be canceled out by negative squares. So if you notice, oops, I took 3 instead of 2, that I only have 3 cubes left right here. Okay, I still have negative 2x squared. I have a positive x squared right here. Now, red squares can only be canceled out with blue squares. Same with the lines. I have 6 lines here. And those can only be canceled out with other lines. So what I'm trying to show you guys by doing this little activity is that cubes can only be added with cubes, squares with squares, x's with x's. That's going to become really important when we put it into practice. So let's go ahead and take a look at number 1. So the first thing we need to do is write that in standard form. So to do that, I need to go ahead and I need to combine like terms. So I see that my largest exponent is 4x to the cubed. So I'm going to go ahead and I need to combine those like terms. So when I add them together, I'm going to keep the exponent the same and only add the coefficients. So I'm going to take 4 plus 3, and that's going to give me 7. And then we have x cubed. So I can go ahead and I can cancel out those cube terms. Next, I notice my next highest exponent is x squared, so I'm going to add those together. I have 8x squared minus 5x squared. So again, I'm just going to subtract the exponents, or subtract the coefficients. 8 minus 5 is going to give me a positive 3, and then I keep the exponent the same. I don't add the exponent. Next, I have negative 3x plus 5x. That's going to give me a positive 2x. Again, I keep the x the same, only changing the coefficient when I'm adding. 8 minus 12 is going to give me a negative 4. So now that polynomial is in standard form. So first it asks how many terms there are. So let's count. There's 1, 2, 3, 4. So there's 4 terms. Next, what is the degree of the fourth term? Well, if you notice, the degree doesn't have, the last term doesn't have an x with it, that fourth term. So that's the same as it being degree 0. So a constant has a degree of 0. That's something new. A constant has a degree of 0. And we're going to go ahead and skip this one because there is no sixth term once we put it into standard form. The next thing we want to do is list out all of the coefficients. Now remember, coefficients are these number factors being multiplied on the outside. Now here's the important thing to remember. A constant is not a coefficient. It's only a coefficient if there's an x involved. So that's 7, 3, and 2. All of those numbers are being multiplied by an x at some point. Last but not least, it asks us what our constant is, and our constant is going to be a negative 4. Okay, let's take a look at this last one here. So we're going to take a look at writing the following in simplified standard form. Okay, so first thing we want to do is combine like terms. Okay, when in doubt, when you're working through these, the best thing to do to start off with is to get it in standard form. So to put it in standard form, I like to start with my highest exponent and combine like terms all the way down. So here I have 3x cubed minus 2x cubed. So I'm going to subtract the coefficients. 3 minus 2 is 1. And then we're going to have x cubed. So now I've taken care of the cube terms. I did, however, miss that x to the fifth term. That's the largest exponent right here. Is that 5x to the fifth? Now, there's no other 5x to the fifth for that to be combined with. So we have 3x cubed minus 2x cubed, which we just did, and that's just plus x cubed. Or you could write plus 1x cubed. It means the same thing. Next, we have negative 2x minus 4x. That's going to give me negative 6x. 4 plus 5 is going to give me 9. So now that polynomial is in standard form. So first I want to find the degree of that polynomial. Now the degree, remember, that comes from the highest exponent. Well, if your polynomial is written in standard form, your highest exponent is with your first term. So I see that it's the highest exponent is 5. So this is a fifth degree polynomial. Next, I want to take a look at the leading coefficient. So to find the leading coefficient, I find the term with the highest degree, which I already put first because I put it in standard form, and then I find the coefficient. So that's going to be 5. The leading coefficient is 5. So I want you to finish these last two problems, 3 and 4, up on your own. So put it into standard form, and then you can go ahead and skip this question again, and then answer the following questions, and then do the same for number 4, answer those questions. So once you're done, go ahead and make sure you take that Schoology quiz, and we'll be going over this some more tomorrow. Thanks for listening.